Hello. Today we're going to be doing some questions from the math sections of the SAT and ACT tests. Now, oftentimes math is one of the most difficult sections for students, and there are several reasons for that. The main reason is a lack of time. Students feel rushed in doing the earlier questions in the section, and oftentimes don't even get to the last questions in each section because they run out of time. So what I want to do today is show you some strategies for picking up the pace. Now, each of these problems, I'm going to show you the correct way to do it, the algebraic way or geometric way, and then I'll show you a nice shortcut or a tip that you can use on this problem and other problems just like this on the test so that you can conserve time and spend that time more wisely on other questions that are more difficult for you on that section. So today I'm going to be looking at questions out of the ACT test. The reason why I'm choosing the ACT over the SAT is because the questions on the ACT math are more difficult than the SAT questions. So what I'm using is the Real ACT Prep Guide. It's the Red Book, 3rd edition, and I'm looking at practice test number 2. The first question I want to do is question number 18. It's found on page number 307 of the book. The question says, the depth of a pond is 180 centimeters. So this is question number 18. I'm going to write it right over here. The depth of the pond is 180 centimeters, and it is being reduced by 1 centimeter per week. So let's write an expression for the depth of this pond. Minus 1 centimeter, and then we're going to multiply by the number of weeks, which we're going to call x. So this expression tells me the depth of the pond. After 1 week, the pond is 179 centimeters. After 10 weeks, it's 170. After 50 weeks, it's 130, and so on. Next, the depth of a second pond is 160 centimeters, and is being reduced by 1/2 centimeter per week. So minus 1/2 centimeter per week and multiplied by the number of weeks. This expression over here tells me the depth of the second pond. So after 10 weeks, the pond is 155 centimeters. After 100 weeks, the pond is going to be 110 centimeters, and so on. If the depths of both ponds continue to be reduced at these constant rates, in about how many weeks will the ponds have the same depth? So in how many weeks will this depth be equal to this depth? So basically what it's asking is for you to set these two equal to each other and to solve for x, the number of weeks. So this is a fairly straightforward algebraic problem if you know how to do this. 180 minus 1 times x is just x is equal to 160 minus 1/2 x. The next step is going to be to add x to both sides. I get 180 on this side. A little clearer, 180 on this side. And on this side I get 160. And then x plus negative 1/2 x, or x minus 1/2 x, is equal to positive 1/2 x. Next step would be to subtract 160 from both sides. That gives me 20 over here is equal to 1/2 x. The last step is going to multiply everything by 2 to get rid of the half. So this gives me 40 is equal to x, and there's my answer. So the answer for this one is choice H. Now this is a little bit complicated in terms of algebra if you struggle with algebra. There's a quicker way of doing this without any need for algebra whatsoever. And what I'm going to do is I'm going to write out the 5 answer choices. They are 10, 20, 40, 80, and 140. Now what I want you to do is to work backwards. Oftentimes on these tests, you could pick an answer choice and work backwards and see which one gives you the right answer, or in other words, satisfies the conditions of the problem. Whenever you're working backwards on a test, always start with the middle number, which is usually C or H in this case. Why? Because then you could go up or down accordingly. You won't have to test all 5 answers, you'll only have to test half of them. Now this one is unfortunate because the middle answer is actually the right answer, but even if it weren't, I'll show you how 20 and 80 give you wrong answers that are very close to the right 40 answer. So let's pick 40 as our answer. Remember, our first pond over here starts at 180 and loses 1 centimeter per week. So after 40 weeks, it has 140 centimeters over here, right? 180 minus 1 times 40, 140. This pond over here loses a half a centimeter a week, but it starts with 160 centimeters. So 1/2 times 40, this term over here is 20. 160 minus 20 also gives you 140. So you have a 140 on this side, 140 on this side. They're equal to each other, so you see that the right answer is choice H, or 40 weeks. Now, if you chose 20 as your option, also a good choice. It's not correct, but it's close. You'll see that the numbers aren't equal to each other. On this side, we have 160, right? 1 times 20 is 20, 180 minus 20, 160 on this side. Now on this side, we have 20 divided by 2 or times a half is 10. 160 minus 10 is 150. So on this side, we have 160. On this side, we have 150. These are not equal to each other, so 20 is not right. This side is too big. If you chose 80, you'll see that this side's too big. 180 minus 80 is equal to 100 on this side, and 160 minus 80 divided by 2 is 40. 160 minus 40 is 120 on this side. So 100 is not equal to 120. In this case, 120 is too big on this side. So the answer lies somewhere between 80 and 20, or in other words, is 40. So using the answer choices on the test often simplifies a lot of the hassle of doing the algebra. Next question I want to do is question number 52, and it's found on page number 316. So question 52, let's do it right over here, is a difficult one, but using approximations, you can find the answer very, very easily. So let me first draw the diagram. It shows a circle, and in the circle there's a rectangle. So let's draw my rectangle somewhere. Oops, let's do that. A rectangle somewhere over here. And it's telling me that the sides of the rectangle are 6 by 8. Now, how do you solve for the area of the circle? That's what it's asking for. What is the area of the circle in square inches? Now, the correct way to do this with algebra is, first of all, plot the center of the circle. The center of the circle is going to be right at the center of this rectangle as well, right over here. And then draw a radial line connecting over here. And then we're going to finish this by drawing a line straight down over here, making a right triangle. The next step is figuring out exactly what the distance is of this radius. So if you see that this whole entire side over here is 6, what is going to be the length of this leg of the triangle? It's going to be half the distance of 6, or the length over here is going to be a 3. All right, and the same thing applies to the 8. If the whole distance of the leg of this or the side of this rectangle is 8, so the leg of the triangle over here, I'm not going to have space. Let me draw a little arrow. Is going to be a 4, half the distance of 8. So this is a 3, 4, 5 triangle. You should know this from math class. So this side over here is a 5. If you didn't know that, you can use Pythagorean theorem. A squared plus b squared is equal to c squared, and plug in our numbers. A squared, we'll use this as our a. 3 squared is 9, plus b squared, this is going to be our b. 4 squared is 16, is equal to c squared. Okay, so I get c squared is 25, and then all you have to do is square root both sides, and you get that final answer, which is c is equal to 5 based on the Pythagorean theorem. So now that you know that this over here is equal to 5, this is a radius of the circle. Remember, the radius of the circle is the center of the circle extending out to any point on the circle over here, anywhere. So this is the point of the circle, that's the radius. So the area of a circle is pi r squared. So in this case, it's 25 pi. We're squaring the 5, which is the radius, times pi. Now, there's a quicker way to do this problem, other than doing the whole entire algebra and geometry that we just did and finding out the same answer. Let's look at the overall area of my rectangle and of my circle. The overall area of the rectangle is 8 by 6, or 48. Okay, and we know that the area of the circle is going to be bigger because the rectangle fits inside the circle. So the area of the circle is more than 48. So let's do the area. Let's call it A of the circle. is bigger than 48. And is it going to be twice the size? Can I fit 2 rectangles into this circle? No. So it's less than 2 rectangles. If one rectangle is 48, 2 rectangles are 96. 2 times 48. So it's going to be somewhere between 48 and 96. So all you have to do is look at the different answer choices and find an answer choice that gives you an area between 48 and 96. Well, the first choice is 5 pi. So let's look at 5 pi. And then you could actually do this in your calculator if you're not sure what 5 pi is. Take 5 and multiply it by pi, and you get an answer of 15.7. 15.7 does not fall in the range between 48 and 96, so 5 pi is wrong. Okay, the next one is 16 pi. So 16 pi, you're going to take 16 and multiply it by pi, and that gives me an answer of 50. So this does fall in the range, but it's very close to the 48. Let's look at the third choice, 25 pi. 25 times pi is equal to 78. So 25 pi is equal to 78. So this one falls squarely inside the range. That's excellent. The next one is 48 pi. So 48 times pi is equal to 150. So that one's already out. 48 pi is equal to 150. So you can forget about that one. Let's cross that one. That means 96 pi is also too much. We could ignore 96 pi. So now you have 2 choices. You have either 16 pi or 25 pi. Now just by looking at the figure that we drew up here, you have a little bit of distance here, some distance here, some distance here, and some distance. Now it's not insignificant, this distance, right? All 4 of these, you have to add them up. So is the area of the circle pretty much equal to the area of the rectangle? Remember, our 48 and this one is equal to 50, so they're more or less the same. So even though it falls in the range, we're saying that the area of the circle is more or less the same as the area of the rectangle. That's not true. These areas over here add up to a substantial amount more than the rectangle. So 78 is the only answer that's going to fit my range squarely within 48 and 96, where it's not so close to 1 rectangle, but it's also not so close to 2 rectangles because that's too much for the area of the circle. So the answer is 25 pi without having to do any of the complicated algebra. All right, the last problem I want to do is problem number 60. This is a very, very straightforward one, but people have a hard time with percentages. This is on page 319. It says Jennifer's best long jump distance increased by 10% from 1990 to 1991. So 1990 to 1991 equals a 10% increase. And then her long jump increased again from 1991 to 1992 by 20%. What's the overall increase from 1990 to 1992 in percents? Now you can't add these up together like you might think you could do, and that's where the mistake comes in for many people in this test. What I want to do with percentages always is pick a starting number. You always want to start with 100. So if this feet is too much, you could call it 100 inches. That's perfectly fine. So her starting jump is 100 inches. What's 10% of 100 inches? That should be an easy answer. That's 10. So her jump in 1991 is 110 inches. Now, what is the increase from 1991 to 1992? This involves a tiny bit of algebra to solve this. It's a 20% increase from 91 to 92. So let's start with a jump in 1991. It's 110. And we're going to multiply this by a 20% increase. So remember, it's 20 over 100. Always when you're using percentages, you're always dividing this by 100. This gives you an answer of 22 on your calculator. So what's the jump going to be in 1992? If it increased by 10% from 100, you get 10% increase, that's 10 inches, it moved up to 110. If it increased by 22 inches, now it's jumping from 110 to 132 inches. So what's the overall increase from 100 inches to 132 inches? This is a very, very straightforward problem. And you'll see that the overall increase in this case is a 32% increase. So the answer to this one is choice F. Don't get confused with the problem. All you have to do is map it out. Always when you're using percentages, write the first number as a 100. It makes the percentages far, far easier to solve. Alright, I hope you enjoyed this tutorial on some of the math, ACT, and SAT questions. Thank you for tuning in. Bye-bye.